Hello. Timmy, can you hear me well?
Yeah, we can.
How's everybody doing today?
Doing good.
Okay, are we ready to turn on our cameras and get started? Yanka? No, you don't. You just have to pay attention. Thank you. Okay. Okay, so it's great to see everyone here today. curaJOY is a grassroots nonprofit that empowers clinicians, parents, youth, and teachers to improve their social emotional wellness and educational outcome together. Behavioral health determines how people think, act, and feel, and it is the foundation of all other life endeavors' success. And we all know that people have not been feeling well. Youth suicide rates, senior suicide rates are at an all-time high. Technology can be a transformative solution in this big global problem and a great equalizer, but it comes with its own problems. We're very happy and privileged today to introduce to you to our 2025 Impact Fellows, youth who are learning the ins and outs of the latest technology, AI and machine learning, in order to shape it for good so that online spaces can be a safer and more beneficial experience for all. So I'm going to pass the mic to Grace Lee, one of our tech fellows, who's going to be presenting today.
Hello, everyone. My name is Grace, and I am a tech fellow for the 2025 curaJOY Impact Fellowship. I'm joined along with my coworker, Rose, and today we're going to be presenting Machine Learning 101, which is a quick workshop on teaching computers to think. So this is designed for beginners. We're just going to walk through what machine learning is, how it works, why it matters, and how we can apply it to real-world problems. So my name is Grace again. I'm in the tech cohort. I'm currently studying computer science and math at Columbia, and I'm interested in AI and high performance computing. This past summer, I conducted research at Argonne National Laboratory, where I contributed to high performance computing systems. Some of my hobbies include dance, cooking, baking, and traveling. And one of the fun facts about me is that I took a gap year to go to ballet school. And if you'd like, you can connect with me on LinkedIn.
Thank you, Grace. So hi everyone. I'm Rose. Grace is my counterpart. We also have Ahmed who did not make it, but we're part of the cohort at this Impact Fellowship. So once again, my name is Rose Njuguna. I majored in computer science at Minerva University in San Francisco, and I'm currently in New York doing freelance software engineering. My interests include AI product engineering, UI UX design, and I love to build inclusive and accessible tech for social good. I'm also interested in social robotics. Things that I enjoy outside of that are photography. I love to vlog occasionally. I love to travel, and I also do performance dance. And a fun fact about me, I really enjoy extreme sports like bungee jumping, highlining, rock climbing, and so on. I am yet to skydive, but yeah, that's a few things about me. And similarly, feel free to connect with me on LinkedIn through the QR code.
Hey, thank you, Rose. Before we begin diving in, what do you guys think machine learning is? So raise your hand or feel free to put your answers in the chat online and we can discuss your ideas.
Feel free to raise your hand, type in the chat. Yeah, there's no wrong answer. Just share what you think. Yeah, feel free to type in the chat, raise your hand. There's no wrong answer. Just share what you think. Use of mathematic algorithms to map data, a way to train AI. I like that. Go on.
Okay, I'm gonna trust that this is on. Ooh, it's on now. I think machine learning is basically just like what Fabiana said, a way to train AI. It it's how the machine, how you like teach the machine and how it learns.
Awesome. I love it. Thank you, everyone who shared. Let's talk about machine learning. So, all of that is right. Machine learning is a type of AI, artificial intelligence, and it allows computers to learn from data without explicitly programming them to do so. So, how this works is instead of writing rules as we would line by line, code by code, we essentially feed data into the models, and then the model will find patterns within the data and use those patterns to make predictions or decisions based on whatever context of application we're talking about. So some examples where you might see machine learning is in recommendation systems. For example, when you see posts being recommended on your feed, whether it's on Instagram or TikTok, or spam filters in your email, voice assistants like Siri and Alexa and so on, or even self-driving cars like Waymo and Tesla. So all these are machine learning. Even Netflix, when that suggests a movie for you or a series that you might like, that's also machine learning because it's learning from the patterns that we already see or based on your watch history and so on.
So here's a quick visual to kind of describe the core components of machine learning. So as Rose said, it's a subset of AI and it can learn patterns from data. Deep learning is a specialized branch of machine learning, and it uses neural networks, which mimic how a human's brain works, by using layers of neurons to process and transform data. And this is used for a lot of tasks like image recognition, speech to text, and even large language models like ChatGPT. Machine learning gets better with more data, and it can improve and adapt over time, which is really useful. It's also powerful for detecting a lot of trends, anomalies, and insights, and can be used in stock trading, disease detection, robots, drones, and stuff like that. And it can make real-time decisions like avoiding a pedestrian or navigating terrain. One of the most common tasks is classification, and one example of this is sorting emails into spam. Machine learning is not just one thing, but it encompasses a lot of things, and you've probably interacted with it multiple times today already. Yes, do you have any questions?
What is the difference between an algorithm and a neural network?
So a neural network is layers of neurons, and each of the neurons take in the data, do something to the data, perform some mathematical operation on it, feed it to the next layer of neurons. There's a lot more behind that, but it kind of is trying to mimic how your brain works by different parts of your brain being more localized and all working together to do one task. And an algorithm is just kind of a general term for finding a way to solve a problem.
Exactly.
Is less flexible than a neural network?
I think they're different things. Like I say a neural network could be considered a type of algorithm. Like algorithm just means finding a way to solve an answer.
Yeah, it's Sorry, go ahead.
Like you can use algorithms when you're doing math too.
Yeah, and different algorithms could work together. So think of it as an artificial brain. There's so many moving parts. So with neural networks, it's like a complex algorithm that is controlling so many things and to realize an outcome that you might want in a particular field of application, like we're doing in our case. We'll talk more about that too. So let's compare traditional programming to machine learning. Maybe that will make it a bit more clear. So with traditional programming, here humans will manually write the rules or the logic manually. For example, a calculator has fixed logic. For example, 3 plus 3 will always equal 6. There's no time where 3 plus 3 will equal 8 because that is a set logic that we will program. And so that is what happens with traditional programming. They set rules that the computer or the machine will utilize to do a certain work or task. But with machine learning, the computer learns rules from the data that we feed it. So, for example, facial recognition software. This one learns by analyzing multiple examples to be able to identify patterns and match correctly that this is, say, Bianca and this is not Clarissa. So it's able to recognize this through learning patterns from the data.
So why is machine learning everywhere? Machine learning is able to analyze massive amounts of data that would be way too much for humans to process. It can also detect patterns that we can't easily see because they're hidden or they're more obscure. It can automate a lot of complex and boring tasks and also learns and gets better with more data. That means it can improve on its own over time. Machine learning is very useful for making fast real-time decisions, such as in an autonomous vehicle, which has to decide, like in a life-saving moment, what to do. Technology has also become much more efficient, especially regarding machine learning in the past few decades. Like you can see on the graph here, the training compute in flops is increasing a lot. And machine learning powers a lot of everyday tools like maps, finding the best route to get to your destination, and Siri, which is trying to help you with different tasks.
Yeah, sorry. So as Grace said, yeah, there's so many examples of machine learning. You probably use machine learning without realizing that you are, like in the example of using Google Maps or Apple Maps. So machine learning is everywhere. Even speech recognition is an example of machine learning where you might input data into your phone through audio. So for the technology to be able to recognize that and understand the language, that's a form of machine learning. Also in health diagnostics, where we're using machines nowadays to be able to identify if a certain individual is sick or not, or, for health reasons, we are able to use machine learning for that. Similarly, with autonomous cars and even advertising for personalized ads, maybe you like soda, you might get recommendations or ads on based on your own interests, which might be different from somebody else because they have different interests, different hobbies, and all that. So even your social media recommendations are all forms of machine learning, and they're all powered by different forms that we're going to talk about.
So there are 5 major types of machine learning. The first is supervised, and we also have unsupervised, semi-supervised, reinforcement, and self-supervised learning. And we'll take a deep dive into each of these.
Yeah, so let's take a look at the first one. So in supervised learning, what happens is we give the model labeled examples. So each example has an input and a correct output, and it's the goal of the model to be able to map the input to a correct output. So emails, for example, can be marked as either spam or not spam, and it's almost like you're studying using an answer key. So you already know what labels exist, and your work is just to match or classify based on those specific labels that we have predefined in our model. So this is widely used in spam detection, medical diagnostics, and so on.
Next, we have unsupervised learning. Unlike supervised learning, the data here is unlabeled, which means there are no predefined categories or outputs. The goal of the machine is then to find hidden patterns or structures in the data based on similarities. And one example of this would be like grouping customers for marketing. The machine can explore the data and cluster it based on patterns. And this is used often in recommendation systems like Netflix, Amazon, and even some other applications like data compression.
So here's a visual comparison of supervised learning versus unsupervised learning, as we've talked about. So with supervised, we're classifying based on labels that we already know. But then unsupervised does clustering based on identified patterns. It tries to group things based on similar characteristics or predefined without having predefined categories.
Next, we have semi-supervised learning, which is kind of a combination of the two before. The input would be mostly unlabeled data and a small amount of labeled data. This reduces the need for full manual labeling when it can be very costly or time-consuming, but we can still improve the accuracy by providing some labeled data. The model uses the labeled data to guide the learning and generalizes the pattern across unlabeled data. And some examples would be speech recognition with limited transcripts, because transcribing speech can be a very time-consuming, costly task.
True. And then we also have reinforcement learning where there are no fixed label data. So here the agent learns by interacting with its environment. So all of the learning happens through interaction. For example, you have seen a dog being trained, and for the dog to learn tricks, there is some reward system that happens where if it does what you expect it to do, you'll probably give the dog a treat. And then as you progress, the dog learns over time. Similarly, with reinforcement learning, with machine learning, we give the agent feedback as rewards or penalties based on the different actions that it does. So if it does something and it's what we expect, then we give feedback as a reward. If it's not what we expect, then there's a penalty, and then it adapts its behavior and learns in that way. So we'll see gaming agents use reinforcement learning. Robots learn through reinforcement learning. Even autonomous vehicles learn through reinforcement learning by interacting with its environment and adapting accordingly.
And lastly, we have self-supervised learning, and this is used in a lot of LLMs like GPT. The input is unlabeled data, but the model is able to teach itself by finding patterns in raw data. One example of this is predicting the next word in a sentence. This can be especially powerful because the model can learn representations without needing labeled data.
So let's talk about how machine learning actually works. So there is a process to this, and the process of implementing any machine learning model has basic steps that we're going to talk about. So the first and very most important thing, in my opinion, is defining the problem and what you're trying to predict or classify. Because if you're not clear on what problem you're trying to predict or to tackle, then it gives a challenge for all. You don't know what data to collect, you don't know what model will be best for your task, you don't know what you need to adjust, what you're testing. So you have to have a clear definition of the problem that you're trying to solve, and that's how we begin any process of machine learning or utilizing machine learning to solve any problem. So in our case, we're trying to tackle online cyberbullying, particularly among Gen Z and Gen Alpha. And this isn't just a technical challenge, it's a social one that many of us can relate to. So we are asking, is this bullying? What type of bullying is it? And how can we address this issue? So we need a clear problem definition because this will help us shape how we label our data, what models we choose, how we evaluate the success of our efforts, or the impact that we actually create. So for curaJOY, we want a system that can detect nuanced, evolving forms of bullying, which reflects how young people communicate today. For example, through slang, we need to understand what language are people using nowadays. Sarcasm, are we able to incorporate that in our models? Memes that people are using, or even silence sometimes communicates a lot. So once we have a clear problem definition, then we can proceed with the next steps.
Next, we have to collect data, and a lot of it too. Our goal is to get a lot of high quality, diverse data. So far here at curaJOY, we've tried manual scraping, AI data augmentation, and now we're exploring crowdsourcing for more data. Ideally, you'd have thousands to millions of examples, but cyberbullying data is not just sparse, but also sensitive. So we're taking really special care to anonymize and ethically curate our data set.
And once we have that and have collected our data, then we pick a model and we train that model. So for basic classification, we might start with a logistic regression, or a decision tree, which might be binary. For example, it's cyberbullying, it's not cyberbullying. For grouping user behavior without labels, we might use clustering and supervised learning, which we talked about. For more complex language patterns, we're trying tools like long short-term memories and transformers. So we need to understand how words relate to each other in the context to be able to use or even decide what model is best to fit our goal and train that to serve our purpose. So this training involves feeding in examples and having the model learn to associate patterns. For example, what emojis are being used, what word choices or tone do we see, and apply labels using that in mind. For example, whether that's bullying or not bullying. Is it spam? Is it not spam? Whatever context, you're able to classify.
Next, we have to tune hyperparameters if necessary. A lot of out-of-the-box models don't typically perform well on the first try. It's like when you write an essay, the first draft usually isn't the best and you want to continue editing to improve it. So some hyperparameters we might focus on are learning rate, which is how fast the model learns, epochs, which is the number of times it loops over the data set, and batch size, which is the number of examples it sees at once. So this can all affect how the model is actually working. We want to avoid overfitting and also underfitting. And that means our model should be able to generalize well to unseen data.
Exactly. And once we've tuned all these parameters, then we want to evaluate the model with metrics. So the key metrics that we use are precision, for example, which is of all the instances that are predicted as cyberbullying, how many actually were cyberbullying? So that's where we talk about how precise our model is. Then we also have recall. And in terms of recall, we're talking about of all the cyberbullying instances, how many were correctly identified? Did it miss any, or did it identify all of them? Then we have an F1 score, which is a balance between the precision and the recall. And finally, we have accuracy, which is just the overall correct guesses of our model.
And lastly, you can finally integrate your trained model into real-world applications for predictions or decisions, and we'll use our model to detect cyberbullying. However, we're also trying to create an AI-powered coach that can respond to these cyberbullying instances and provide resources. So it's not just detection, but also prevention and support.
Let's talk about the spam filter as an example. So in a spam filter, your inbox is the data source. So how this works is the model will learn what spam looks like based on sender information or the language structure that is in the emails, and then be able to predict whether this is spam or it's not spam. So it applies this knowledge to new messages that are coming in to filter them in real time. So as they're coming in, it analyzes and classifies them as either spam or not spam.
Another example of machine learning in life that you've probably interacted with is YouTube recommendations. So the model will look at the types of videos you watch, how long you watch, what you skip, and your engagement, like likes, dislikes, or comments, and then suggest more videos you'll likely enjoy. So one cool thing about these models are that it changes in real time. Like if you notice one night, if you stay up till 4 a.m. watching Minecraft videos, the next day it might recommend more Minecraft videos to you before, even if you've never watched Minecraft before that.
Yeah, so let's talk about how we can understand how well a machine learning model works. So there are four key terms that we use to understand this. We have true positives, false positives, true negatives, and false negatives. So I'm going to explain this using something that we can all resonate with, or something that is more familiar to us. So for example, a COVID test. When I'm talking about a COVID test, if I want to define this in terms of a machine learning model, if I have a true positive, this is when someone tests positive for COVID and they actually have it. So the machine learning model or the test actually confirms that the person is positive. So we can rely on that. A false positive, on the other hand, is when someone tests positive but they do not have COVID. So the results show that it's positive, but they do not actually have COVID. We have true negatives where the patient does not have COVID 19, but the test correctly says that they are negative. So it is a correct indication that they do not have COVID. And then for false negative, it does say that the patient does not have COVID. So it tests negative, but the patient does indeed have COVID. So it's a false conclusion or result from this. So we're going to see how these terms can help us understand or make decisions as we're approaching or as we're dealing with different problems where we're utilizing machine learning.
So let's talk about the impact of these classification errors. So type 1 error is a false positive. That basically means you think there's a problem, but everything is actually fine. And type 2 error is a false negative, which means you think everything is fine, but there's actually a problem. Balancing these two types of errors are critical depending on your domain. For example, having a spam email in your inbox is annoying at best, but having an important email that's marked as spam, such as a job offer or a bill, means that you miss that, and that can be very dangerous. On the other hand, when you're trying to do something like cancer detection, a false positive would mean that a healthy person is told they have cancer, and they might have to go through some stress and extra tests and screening to make sure that that diagnosis is right. However, a false negative would be even worse. That means your cancer was missed by the test, and the patient doesn't receive any treatment, and the cancer progresses, and this can be extremely dangerous and even fatal. However, when we're looking at these types of errors, it's important not to just look at accuracy. For example, if 1% of people have cancer and 99% of people don't, and your model predicts 100% of the time that people don't have cancer, then it does have 99% accuracy, which you might look at and say, that's really good. But it's missing 100% of the cases where people actually have cancer, and that can be really bad. So it would be a horrible model, even though it has great accuracy.
Yeah, so I want you to keep that in mind. Think about the errors. I want you to start thinking about what the implications are for different case scenarios. So in our case, where we are doing cyberbullying detection, our goal is not just to detect cyberbullying. We want responsible detection, which minimizes harm, but also maintains safe and authentic communication. So we're going to discuss the classification errors with respect to our curaJOY course. So, in high sensitive contexts, for example, where we have young mental health users, for example, on social media, a false negative in this case would mean that we skip intervention and we don't identify a harmful message or image as harmful, and this might cause lasting damage if we do not detect that. In false positives, we can harm the user's trust or reduce platform engagement because we flagged something as cyberbullying when it was harmless. So I want you to think about and share your opinions in the chat about which one you think is worse before we actually dive into that.
Do you have any thoughts?
In person.
Feel free to raise your hand as well and share.
Go around the table.
Okay.
Personally, I think that the false negative is more dangerous because there's a lot of cyberbullying, and a surprisingly large amount of it goes unnoticed by the AI algorithms. And I think that should change. And true, being flagged by a bot, by an AI moderator is usually a nuisance at best, unless it deletes the account, but I don't hear that happening too often.
That's a good point. Anyone with a different opinion or agreement?
Wyatt agrees with
Okay.
Bianca's reasoning. And he said that he agrees that the false negative is the worst. I can't read. Error. I thought that was emo. Okay. I also think that the false negative is one of the worst errors for cyberbullying detection, but I feel like false positive could also be a decent one as well, because if there are serious repercussions, then no change will be enacted because the wrong things will be flagged.
All of that is true. So
And Grace also said something, I think.
I think
Grace said,
another
Mhm.
I think
Sorry, go
another thing to be concerned about is like for false positives. Here in America, we have free speech. So everyone has the right to say whatever they want. And if it's harmful, then that makes sense to be moderated. But if they're just trying to express an opinion without hurting anyone, then they can feel like that's kind of like a censorship type of concern.
Yes.
Absolutely. Waki, you have your hand up. Feel free to unmute.
Okay, greetings everybody. Am I audible?
Yes.
Hello.
Okay, I would like to request for this material to be sent to everybody that needs it. I think I'm of interest. Yeah, is it possible for us to have it on PDF? Send to our email.
Yeah, of course. This is a lot of information to absorb, so we're happy to make this material available online.
And we can send it out after
Okay,
to everyone who participated.
sure.
okay, no
Now
problem. Thank you.
Now let's dive in a little bit more to each type of error and the impact. So like everyone said, false negatives can have a very high cost. That means an actual instance of cyberbullying slipped through the cracks and it doesn't get flagged. This can be dangerous because it's a type of failure on the AI moderator and the model misses real cyberbullying. So the victim continues to suffer silently while the abuse continues. And in some situations, it might even escalate if no one tries to intervene. Also, this could lead to a false sense of security for users and their parents who believe that a platform is accurately monitoring cyberbullying. But if they are still exposed to that cyberbullying content, it may change their trust in that platform, and you can't really repair that. There's also a lot of real world mental health effects, like victims can experience anxiety, depression, isolation, and even self-harm.
Sorry about that. Yeah. So there's also false positives, which some of us also mentioned as harmful. And there are cases where the model incorrectly flags something as harmless, but incorrectly flags something harmless as harmful. So at first, it might seem like the safer mistake to make because it does not really impact individuals negatively as much as false negatives do. But there are real consequences here too, because we'll see that it limits freedom of expression. At first, it might for example, wrongly punish users, for example, suspending someone for a sarcastic joke or a misunderstood meme. And this starts to limit their expression on these platforms, even their engagement. So it can also lead to frustration, confusion, and people just don't want to interact with the platform anymore. And so we see that even users wrongly accused or silenced may lose faith not just in this system, but in the entire moderation effort. So they lose trust in the process or what we're trying to accomplish with these tools. And if this happens too often, people will no longer trust the anti bullying tools, and it kind of beats the purpose or our goal for creating a safer online environment for everyone. So while we want to catch harmful content, we have to do it in a way that will not penalize harmless behavior. Otherwise, we risk losing the community's trust, and we do not want to do that. So, yes, we might prioritize false negatives, addressing false negatives, but we also want to think about how false positives might have certain implications that we want to avoid.
Also, using machine learning or AI can raise a lot of ethical questions, including bias, accountability, and even environmental concerns with the training the AI models. Some big examples of these types of questions, like so should engineers be held accountable for offensive responses generated by AI chatbots, or who's to blame if an autonomous vehicle crashes or if an algorithm makes a misdiagnosis? Like who's in charge of that? Do any of you have any thoughts about that?
Yeah, what do you guys think?
I have another more specific question, I guess. So say you're sitting in the front of your self-driving vehicle and it's driving on its own because it has the ability to do that, but you're still sitting there. And then your vehicle gets into a dangerous situation and crashes. Whose fault is that? Is it the engineer who made the vehicle, who wrote the code? Is it your fault for not intervening in time? Or is it the business owner's fault for allowing this to slip through the cracks? Obviously, people who sell self-driving cars are not trying to kill everyone who uses them. So who takes accountability?
That turned into a bit of a philosophical question, I feel. Yeah.
Yeah, but it has a lot of relation to when you're actually using AI because you can't always moderate everything that it says or does.
I think we have to consider the severity of the consequences. If it's life or death, then companies, for example, medical device companies, diagnostics, they can go through FDA as a mistake would really impact a person's life. It's life or death. But there is a fine line because at which point do you squash innovation?
Mhm.
Engineers, researchers are not going to innovate if they think every mistake will be punished.
Exactly.
Exactly, yeah.
I also think accountability and responsibility comes down to two different things in this case, because if the car were to crash, I think the owner of the car would be most likely responsible. But then again, like because of the severity of the accident, depending on how severe it is, I think that's the company or the engineers or the owner of the company is more accountable for that.
So those are all really great insights, and there's a lot of controversy over these questions. So, yeah.
So yeah, I hope that was fun. Time for a quiz.
If
Feel
you
free
want to
to-
talk about it
Sorry.
again later. Oh, and you don't think an engineer should be held accountable, but the company should be held responsible because it's their job to test it and make sure it's safe and catch any mistakes. I think that's a very good.
It's 100% guaranteed and it isn't that different.
I feel like a lot of cars, especially right now, because they're a little newer, they say like, oh, it's not 100% on the vehicle because you're supposed to sit there. And if something happens, you're supposed to step in and make a decision. Oh, okay.
Wait, you mean by the engineers and the person who created it?
Or like the engineers. Yeah.
Yeah. Yeah, so there are a lot of ethical questions around this and who should take accountability.
So it's automated driving, but you have the person sitting in the driver's seat have to have their handling driver steering. Because if you let go, then it'll automatically disengage. Then control.
Okay.
So that's
Mm.
major, I think.
Yeah. So also like each company will handle it differently depending on it.
This is a warning saying like this is not 100% accurate. It might be problems. Please be mindful of that, or some kind of warning like that. Like it's not 100%. I think they even have that too.
And a lot of like chatbots also they're designed not to say like offensive things, but some people might say that's a form of censorship, or they have a lot of like political tests for the chatbots, and they're like, oh, you can see that certain people are trying to spread their agenda through chats. That can also be a really big question that people talk about. There's an isolated incident. An individual vehicle should be studied to find which step in the manufacturing program failed, but if it's not an isolated incident, then every person that was part of the process should be held to some degree of accountability. It's also a very good thought.
Yeah, thank you, Grace.
This is a weird thought, but maybe there are some times when nobody was at fault. It was just a problem because you can't, not a lot of things are guaranteed in life. For example, if a medical test accidentally gives you the wrong diagnosis, yes, that's incorrect, but what did you expect? The people who created them are only human. They are not 100% accurate. Sometimes I think that if a test has a high enough accuracy and it sometimes still goes wrong, there isn't really that much blame. I don't want to sound like one of those crazy people, but do you understand what I am saying?
I totally agree with you with it's still made by humans, and even though it is trained and it's trying to be more accurate, like if you have a human doctor trying to treat you, they could also misdiagnose you. So it's not all up to the AI or the model. Or like when you're driving, like lots of human drivers crash a lot too. So it's not fully on the vehicle or the test.
Yes, and is it on the company who decide to use the test? Because what else are they going to use?
Yeah, like someone is probably going to be held accountable. Like if you have a loved one who gets misdiagnosed and they die from, you're probably going to want to take some action, but who do you go to?
Like if someone tells me like, oh no, sorry, we actually didn't screen for colon cancer.
Yeah. Or it's like, oh, sorry, like sometimes the test is just wrong. Fix the problem.
Yes,
There's been a few parents who sue social media platforms and chatbots for their kids' suicide, attempted suicides, or other behavioral health problems. It's an important issue to tackle, but your kids can still be addicted to drugs, alcohol, can commit suicide even with a human therapist.
Yeah.
Human therapists cannot guarantee results.
Like, are you going to blame the therapist for like not preventing your child's suicide? Or are you going to blame the parent? There's a lot of factors that can be like thought about this.
It's a very slippery slope.
Mm.
Okay, now we'll move to something a little more lighthearted and we'll get to the Kahoot that Rose has prepared. So if you all want to take out your phones or laptops and join, yes. And the winner gets a high five. Does the winner get I thought those.
I think they get one more entry into our raffle for $50 gift card.
Those have water bottles.
But they're all not here. How are we giving them the water bottles? Oh, okay. If you really want the water bottle, we can send it to you.
Yeah, I'll give a couple more minutes for more people to join.
Wait, Rose, can you go to the Kahoot screen?
Yeah, I'm there. I'm
That
waiting
should be
for a
able
few people to join. Yeah.
I think the entry screen will have the pin on it.
It does. It should be
Okay.
the same one that that is on the slide.
Okay. Yay.
404175.
Mhm.
Yeah, I see people joining, so let me know if you have challenges with that.
We've seen this like twice already. So Julie and Bianca clears up, and we go Julie and Bianca, and we really kind of embarrassed if we don't bring.
Yeah. Yes, I can't see.
Oh yeah, that's because you guys. Yeah, if you're only your name is displaying, you're in because that's how Kahoot works.
Wait, what? Wait,
I need to start the game.
Okay.
yeah.
Actually.
Can
I
we
started.
go to? Can we switch your? Can you switch your screen to the Kahoot because we need to, so then we can share also here.
Okay, 1 second.
That's the problem with Kahoot. I see shapes.
Oh,
Which one is it? Is it the square answer?
I think it's because the answers and questions are all on.
Yes. I don't like Kahoot.
We're getting there. We'll make sure everyone's separated.
It says time sucks.
Oh. Wait, can we restart it so that everyone has a chance to?
Let me see if that's possible.
Sorry, guys, technical difficulties.
No. If I exit, it might generate a new pin. Let me see. 1 second.
Okay.
Yeah, sadly, we need a new pin for that.
You're gonna
Can
have to rejoin. Thanks.
Yeah, sorry, everyone. Please rejoin using the new code.
Are you able to play the music?
Is it not playing? I can hear it. I don't know if you guys can.
Did you share your audio with us? Like,
Sorry if I cannot do that.
There's so many people. You guys have a good soundtrack.
well, I think it's just the Kahoot music,
Huh.
but it's better than being like silent.
Funny chicken.
Yeah, I'm not sure how to share audio.
No, we still don't have the music, but it's okay. Well,
I typed
mm,
my nickname and then it became funny chicken.
oh,
We can do it with our
Sorry.
mixes, like, how about like acapella Kahoot?
Rose is enjoying the music. I think that's everyone. Because
Alrighty. Ready? I'll start now.
so question number 1. What does unsupervised learning mean?
Please don't say I couldn't create.
You should probably read the question out loud really loudly after.
Okay.
Mm.
Okay.
Okay.
Yay! Wyatt
Wyatt.
is in first place. Funny chickens in second.
Keep going.
Next, in unsupervised learning, the model groups data using
Nice
Yay,
work.
you all got that one right. Very proud.
Awesome, awesome. All right.
Let's go, Clarissa. Spam filters are an example of oh. Yay. So spam
Yeah.
filters are an example of classification because it's spam or not spam.
Yeah, so
So
they're
what?
predetermined labels. Wyatt's still up there.
Got speedy fingers.
Mm-hmm.
YouTube recommendations use what kind of machine learning?
Dang it.
This one was a little tricky.
Yeah.
It's a little trickier, but yeah. Why it is still up there. Deep
Mhm.
learning is a little more complicated and uses a lot of neural networks.
Yeah.
Kind of. It's a little less. It's more like more layers. They're all a bunch of things. What's most important for detecting cyberbullying?
Nice work. Somebody give Wyatt competition. Fight for first place.
What happens first in building an ML model? This is when you're actually building it. You can't feed it data if you don't have data.
Yes, you have to first collect the data, lots of it.
Finally.
Hey, funny chicken's back up.
Yep.
We're halfway through. Why are most existing cyberbullying detection tools missing the mark? Oh, I don't think we.
That's true, though. That's
Well, like. Yeah. Why? Machine learning models always make fair and unbiased decisions.
It's true. There's a lot of biases, and we can avoid this by feeding it diverse data.
You get points if you get the right answer, and more points if you do it faster, and 0 points if you get it wrong.
You also get 0 points if you run out of time and don't click
Yeah.
anything.
Yeah.
Yeah.
'Cause which type of machine learning is most like training a puppy with treats for good behavior?
Reinforcement learning. Learning through interaction, and you get rewards or penalties. Clarissa is back in the game.
Yay. 3 more questions. A simple calculator is a good example of.
Great work.
Yes.
Yay, funny
Maybe we
chicken.
made maybe we made this too easy.
Why you get something wrong?
Yeah.
What is the special ingredient needed for supervised learning?
I use a semi-automatic.
The clicker.
Correct.
Everyone got it right.
Good job. And I think
Mhm.
one more question.
One more, yeah.
Which approach can find natural groups or segments with a massive collection of data without any pre-existing labels? Yay. See.
Yay.
The final podium, we have Fresh
Mhm.
Puncher in third place, Funny Chicken 28 second place, and Wyatt in first place. Do you want a water bottle? Do you want a water bottle? Now we're going to pivot back to our slideshow and kind of talk about what we're doing here at curaJOY and how we're applying what we learned today to our fellowship.
One second.
The message you sent is kind of like, that was one night. I'd like to take a survey of whether any of the participants have had previous exposure to machine learning. Quite a bit of information.
It is a lot.
Yeah.
So what we've done so far, we've began building a youth-focused cyberbullying dataset that focus on Gen Z and Alpha. And that just means people born after 1997. So far, we've tried manual scraping and AI data augmentation, which is like asking AI to help produce data. And now we're exploring crowdsourcing. We've also reviewed some previous research and found gaps in the current data sets. And we've noticed that some age ranges and newer platforms like Discord, Snapchat, and BeReal that are used a lot among younger people are not really included in these data sets, which typically include like Instagram.
So this slide right here introduces the annotation schema that we're going to use to label and categorize cyberbullying. So for us to be able to have consistent high quality data for machine learning, we need to create a shared language around certain categories that we're going to use for this classification. So for the purpose of our project, we've broken down cyberbullying into 4 main categories, where we have verbal violence, which includes harmful or aggressive language. This is the most common form of cyberbullying you'll see, and it ranges from insults and threats to harassment, even hate speech. So it includes both written and spoken forms, whether it's on a comment, a post, or something that is said in a video. Yeah. So verbal violence is pretty advanced, and we are aiming to address that as one of the categories.
Next, we have visual violence. So this includes any harmful image or video sharing, and that can include memes that are deliberately trying to shame or harm someone, deepfakes, which is AI-generated media or AI-manipulated media, non-consensual posts, and screenshot shaming or sharing personal private messages that without consent.
We also have exclusion as one of the categories, where someone is deliberately left out of group chats or shadow banning, secret gossip group, and so on. So this might seem less direct, but it can be damaging to social and psychological welfare of individuals. So it can be just as severe, and we will address that as well.
And lastly, we're grouping everything else into the other category, which includes hard to classify instances of cyberbullying. This can include cyber gossip, impersonation, catfishing, and other forms of hybrid behaviors. Having these categories are very important because they guide how we're actually labeling our data and thus how our model performs and is able to detect the cyberbullying. And it also gives our reviewers a clear guidance on how to label the data.
Exactly. So what are our next steps? We are looking to train a machine learning model that will detect cyberbullying in real time, but we also want to build an AI coach that suggests constructive responses and resources to individuals or victims of cyberbullying. So our goal will be to create this supportive and real-time intervention, not just to flag bad behavior. Because if you identify the problem but offer no solution, then you've almost done nothing. So yeah, that is our goal, and that is what is coming next.
So here, we're going to ask you for a little bit of help. Like as we talked about, we're building a model that can recognize cyberbullying, but our model can only be as good as the data we feed it. So we're trying to crowdsource our data. That's where you come in. If you have any instances of cyberbullying that you've experienced that cross the line from annoying to harmful, we'd really appreciate if you would share that, including the surrounding context with us through this form. Also, we'll make sure to remove all of your personal information so you don't have to worry about privacy. We want to make sure everything is anonymous and no one gets harmed in the process. And we'll really appreciate any help that you can provide. If you want to.
Yeah, please scan the QR, take a picture, share it on social media with your friends. Help us collect the data to serve you. I'll give 1 more minute for that.
Yeah. Yes, we can share this slideshow after the presentation and send it
Yeah.
out. And if you have any friends who want to help us with crowdsourcing data, that would be very appreciated.
Please and thank you. All right. So it's not like there's not already existing tools that aim to address cyberbullying. But what we've noticed is that most current anti cyberbullying tools are actually outdated and they do not understand how younger generations actually communicate. So we have memes, we use sarcasm, we use jokes and all this, but the models that are existing in the market today do not address this, or they miss out on this, do not pick up these nuances, which then fail to actually solve the problem of cyberbullying. And social media or online is still unsafe for Gen Z and Gen Alpha. So that's why we're aiming to actually address these concerns, because emotional wellness needs to start where people are. We need to understand what is actually going on, how are people talking, and how can the tools that we build actually serve them.
Thank you all so much for coming and taking the time out of your day to join us. We'll be doing a raffle for the participants, and the winner will get a gift card. Also, I believe everyone who joined will get a free DataCamp subscription. DataCamp is a great tool if you want to learn anything that's coding, AI related. And in the meantime, we're going to continue building tools that are smart, ethical, and compassionate. Thank you so much for coming. And we'll
Thank
share
you,
this.
everyone. Thank you. Thank you.
What's going on in the chat? Big round of applause for Grace. And row. And row. Great, you guys are coming.